In tonight's lecture, we're going to learn how to do what we call part number 4 of 24, right over here, in Autodesk Inventor, right over here. First thing we want to do, as we always do, is when we start a brand new drawing, is turn all of our planes on. The way I did it that fast was I clicked on the first item, held my shift key down, picked up last item, right mouse button, and visibility. I like to say go home because the little house looks just like that, so I can go into the isometric view. Then I look at my part and make a decision of how I want to build it. This thing basically has a center piece, which is this item right here. Okay. It has an extension right over here. That's tangent to it. It kind of looks like the letter C to me. And that's a very, very bad, very bad image there. Sorry. It's got the centerpiece here. So it's got this piece in here. Okay? And then we have this setup over here. This is tough. When you look over here, this is visually challenging. If you look at this piece here. And I can appreciate all of you having a struggle with this. Before we started this lecture, you're like looking at me going, huh? I understand. This thing, I'm going to change colors real quick. There's a wraparound here, but it's not tangent. It's not tangent to this big circle. This big circle is a diameter of 2, which means it has a radius of 1, but this thing has a linear distance. You know, initially you might think, oh, that's radius. No, that's a linear distance of 1.3. So if I look at my distance here, it's going from here to here, a distance of 1.3. Okay? That's a linear distance. It's not tangent. A tangent would be a much larger number because if you look up here, again, the diameter is 2, so the girth of it, you know, you're thinking, what kind of matchup would that be? It would not be 1.13. It would be a bigger number. This thing is limited to 1.13. And then, of all things, it tapers in. And the taper in is also a little interesting. It's, of all things, right there. And that, I'll write it a little bigger up down here. It's 8, literally 8 degrees. That's that taper. So it tapers in, toes in, think of it that way. It angles in, if that word makes more sense. It angles in 8 degrees. It tapers. Technically, I'd call it a taper. It tapers in 8 degrees. So it's really neat. Very difficult to look at, though. And no, the students have asked in the past, well, okay, if it does that, why don't I have the distance of it on this side? I'm like, it doesn't need it. So no, you don't have the linear distance. It just goes in 8 degrees. The limit is right here, the 2.88875, that number. Where this center is, and this center, okay, this radius up here, that's where it gets cut off. That's it. That's all you need to know. You don't need to know the actual numeric value. So the only numeric value you're worried about, or set of values, is the 1.13, which is 1.125, because 1.3 is rounded, the 8 degrees, and how it matches up to the side of this wall. As you can tell, it does it at an angle of 45 degrees. So you have to pay attention to that number. With that in mind, if I try to sketch this out, it's roughly at 45 degrees, and it kind of looks like this, with a circle, a hole, okay? So the centers, ooh, that was very poorly drawn. Yeah, I saw that look on your face. I'll take out the centers. but that's roughly what it looks like. All right? So when we try to emulate this here, we have to think about strategically, how are we going to build this? Here's what we can tell. This center object down here, the center circle, has a diameter of 2. Is it flush with this, the bottom of it? What I'm circling, yes or no? The answer is yes. Up here, if I look at this guy, the same 3-inch diameter, it's just the top of the cylinder. Is it flush with this or no? The answer is yes, it's flush. These two are flush with each other. They are flush linearly, they're aligned with each other, linearly aligned. So they are actually lined up with each other. Not that my line is, to be honest, but they are. Let's try that a little slower. I still can't do it. Sorry. All right. So these two are lined up with each other here, and these two are lined up with each other down here. Okay? That's your matchup. So over here, I'm going to start with the middle object, because that seems to be the catalyst of everything else, because the extensions off of it are added arms. Think of it that way. So I'm going to go ahead and create a sketch. I'm going to draw it the diameter I need it to be by going to Create and Circle. I was a little too fast in that motion, so let me undo what I did. Create circle. When I click here, you'll notice that my dimension thing comes up. As long as I don't click, I can actually type my value in here, hit enter, and save myself the trouble of adding the dimension later. Please remember that. It's just a quicker feature to be able to build. Gesundheit. I only build my one object and I go straight to extrude. The height that I want to extrude is the height of the object, which is given here. And that height, let me highlight it right there, is 2.5. That is this vertical height of this object. This vertical height. So that's what I'm going to type in here, 2.5, and done. Now I basically have the top of my object and the bottom of my object. Notice? So if I clean up my drawing a little bit, just a little bit. I want to take everything out, clean it up. There we go. By drawing my center cylinder, I now have some references. I have a top reference and a bottom reference to make my other objects. Here's my top reference up here. And I can pick this face to build this item here. I am building each entity discretely, individually, so that I have complete autonomy of how I handle them. So I'm going to pick this top face, create sketch, and then I'm basically going to build this other object. Now, appreciating what we've discussed in the past on building. Ooh, did I go too fast again, guys? Yep. I have to teach myself to slow down. When I click here, let go of my mouse, I can type in the numeric value of what that one is. It says 1.06, which means it's probably 1.062. Hello. Let me try that one more time, sorry. All right, come on you. There we go. Circle. Here, let go of the mouse, 1.0625. And the reason I keep doing that is because we build to the real size. We do not build to the tolerance. The tolerance is the 2 decimal places, not the actual size of the item. Whenever we see 0.06, something of that nature, remember to go into your, I think it's somewhere in here, the chart, the decimal equivalency chart, to make sure you use the real decimal value and not the toleranced one, because in the grand scheme of things, whatever we build in here, we have to presume is going to be taken as a 3D model and sent to, for example, a 3D printer, or sent to a CNC. Okay, so no human's going to get a chance to look at that model and verify that the dimension is a true dimension versus a tolerance assigned dimension. A true dimension is 1.0625. The tolerance dimension, which is what's on the printed drawing, is 1.06. Now that 0.025 may or may not matter, but let's assume it does. It's better to err on the side of caution than the other way and say, it's okay. No, it's not. The next dimension we want to drop in is its location relative to the other object, which is 3 inches. Now I dropped in the distance and I dropped in the diameter, so why is it still green? Green means that it's not fully constrained. It requires one dimension. One way to test the object, I'm going to use a very scientific term, wiggle it. We're going to wiggle it. Let's see what it does. We're going to wiggle it. Notice? It's locked in at the 3-inch marker, but it is not locked in horizontally. Notice that? See that? So it wiggles about that axis. So what we need to drop is another reference. We're going to drop a line, literally a line connecting these two objects. We're going to turn that line into a construction geometry because we want to use that line to help us constrain this object, but the line is not going to be part of the extrusion. And if we have crossing solid lines, will my object ever extrude? Nope. So I need it as construction geometry. Then I can pick this item and constrain it. Get it a constraint. Where's constraint? Where's constraint, guys? Do we have it in our list of things to do? How would I do it? I can click on it and do a right mouse button. Well, how would I? If I show all constraints, that's not good enough. If I go to the properties of the object, that's not good enough. So how can I constrain this? I can click on it and do what? I can go to constraints and pick horizontal. Inside the object itself, if I did, if I chose the following, if I click on the object and right mouse button, I get delete, undo, construction. Construction's checked on. Center line. I can display degrees. I've got all of these options. Display degrees of freedom, delete, snap to grid, choose loop, show all constraints. Properties. When we clicked on properties, constraint wasn't one of the options. Further down, you have show input, additive, view, help topics, look at. If I turn this back into a construction line, just turn that off. And now I click on it. Come on, you. Right mouse button. I do get the option to turn it into a constraint, but I do not get an option to add a constraint to this object. You notice that? I can show all constraints, but I can't add a constraint. So I can turn a line into a construction line on the fly, but I do have to go up here to assign a constraint. Now, did I make that correctly? No. I'm going to leave that in there just for fun. If I go to 3D model, create, and extrude. Oh, look at that. It did let me pick it, even though that line is intersecting with it. I'm going to change direction. Now you notice this? I can actually adjust this manually by pulling the arrow up and down. Or I can do what? type in the number, but I'm not going to type in 1.38. I'm going to type in 1.375. So this is an example where the line is actually okay. It actually did not fight with my object. You will find that in some cases it will. So my general rule of thumb is turn it into a construction line. It's not going to hurt you. Next, I'm going to finish my sketch. There's my extrusion. I go to the bottom. Now what? What do you think I should do? See how I flip that? When you click on the corners of the cube, you're allowed to do that. It'll let you do that. If I click only on front, it'll lock to the front. The corner will give me an isometric. I want to build something off the bottom of this part. When I create another extrusion, I create a 2D sketch right here. Notice it goes upside down. It literally sent me to the bottom. If I go home, go to the top, now I'm looking at this object from the top. Be very mindful of that. That's one of the issues people have, is they'll draw something, and they don't realize they're on the underside of the part. And they'll reference this as if it's here. Because in this view, it kind of looks like it should go down here, doesn't it? And then when they go to isometric, they're like, hey, where did it go? Why is it back there? That's really because you got to look at it from the top to make sure you position it correctly. Please do that. Please make sure to do that. I'm a creature of habit. I turn that into construction lines. It's never going to hurt you to do that. I dimension this thing. This thing's a dimension of what? 1.5. How far away is it? It fights me. Okay, watch. When I go to constraint and pick dimension and I pick the line, it wants to do horizontal. It wants to do, horizontal or vertical. It won't give me the hypotenuse. Right mouse button and pick a line. Okay? Yep. I see that look on your face. You gotta pick a line. Then you can get 2.875. That's how to do that. It still hasn't, it needs one more constraint because it's still green. So again, that scientific approach, I say that with a joke, how do I control? Oh, it wiggles. It wiggles around the axis, which means it needs an angular constraint. So over here it needs this. It needs an angular constraint. Because it has an angular constraint, right there, I got to put it in here. So I have to pick my plane and my line, and voila, I will get 45 degrees. When I go home, I can go ahead and I'm finished with this sketch. I can go ahead and extrude it. It wants to extrude down. Why on earth would it want to go down? Remember which plane we picked to build the object on originally? Down here. That's why it wants to naturally extrude down. So all you got to do is drag the little arrow and drag it up. And that's where you get your next dimension, which is 1.375. And there you have your basically, it looks like 3 little cylinders, one floating in the air. If I look at the front of the view, it should look something like that. Because I'm recording this, I'm just going to keep plowing through this. Normally I would stop and say, now it's your turn. And then we stop and go over the next step. In this case, I'm going to actually do the whole thing. So you have everything. Next step would be to go ahead and let me stop myself. Hold on. Over here. We've got this down, so these are done. Basic shapes. Remember that. We build everything up and then we whittle away at it, a whittle at a time. Always think that way. I want to do all my cuts at the end, not in the beginning. I do want to add these next, which are the webs. Some people call them webs, some people call them ribs. There's a couple of names people give to that. We could attempt to use the rib command to make this, which is right there. But first, we need a place to drop the rib. That place, we notice, is 1/2 inch below this top piece. So the best way to do that is to add a plane. So I hold my left mouse button down. I selected that top face. I'm going to drag my mouse down. And then I'm going to actually type in. Now you notice it changed to a negative value because I'm going down. Negative 0.5. So it drops down. That's the plane. That is the plane that I want to build my sketch in. I'm going to go ahead and create lines. And just like with the other example we discussed in class, that inclined plane project, I do draw my lines far, far away from everything. Because tangency is difficult enough as it is to find it. So I'd like to pick my object. I'm going to hold my control key down, pick my other object, and then assign tangent constraint. I'm going to rinse and repeat this to this, done. That's locked in. This to this, it'll keep going. That's the beauty of this. Boom, boom, boom. That's it. It knows to do that because I've selected tangent the way I did it. Now, again, the way I did it, that's what matters. It was done in the following manner. Pick the object, hold your control key down, pick the circle. As far as order, that order doesn't matter. I could pick the circle first, hold my control key down, pick the line, okay? Then jump over and pick tangent. I just tend to pick the line and then the circle is just how I do it. You can easily pick the circle and the line and you'll be fine. It's okay. That order doesn't matter. You'll still get the same outcome. When I do this and I go home, you see how it dropped in some little yellow reference geometry to achieve that outcome. I didn't do that. The computer did. I didn't do that. The computer did. Okay? That's the piece I want you to appreciate. So don't stress out. Oh my God, I forgot. No, it does it on its own. I can go ahead and trim, and it knows to trim them to its tangency reference. Now this is a little difficult back there, so I kind of have to turn it around to make sure I trim correctly. And there you go. I could at this point try rib and see if it works. Pick this object and this object, just for fun. And pick this. Is that a profile that I can work with? Nope. The rib won't work here because it's not technically considered a rib to this software package. So here I have to basically extrude it. I can pick it, voila, change the direction, and the distance is what? 0.375. And I hit OK. That's your first rib. The next one is not so straightforward because this particular one, as we already discussed at the beginning of this lecture, is not tangent. It is referenced from the bottom, the 1/2 inch. So it's off my bottom plane. So I can go ahead and create a plane. I can choose the bottom plane, or as there's a school of thought, which should I do? Should I pick the plane or should I pick the body? I'm going to be in the school of thought of pick the body, because if I ever move the body, I want my plane to make my rib to move with it. If I don't pick the body, instead I pick one of the standard planes, if I ever move that body, do you think my plane's going to move with it? The answer is no, it doesn't. Negative 0.5 is that height. Let me go home again. Now, you'll notice the color. The color is like a bluish color on top, and you'll notice the other planes are a yellowish color. The yellow side means positive. The purplish, bluish side means negative. Does it really matter for what I'm doing? Honestly, no, but just be aware of it. I do pick that plane and go ahead and create a sketch. Now, this is where the fun begins. I'm going to create a line somewhere in this object, because I don't really know where to put it yet. When I touch that object, you see how that dark black appeared? That's the reference geometry that the object is, the software is putting in. If I go home, do I see any reference geometry? No. Notice how I saw it last time, correct? It dropped it in automatically, but not this time. So, we can try to trim and see if it'll work. Trim the whole line off. Oh gosh darn it, gee willikers. Can I trim to nothing? No, I'll get nothing. So I really do need to put something there. And this is where people ask me all the time, why do I use, or when, not why, when do I use project geometry? Now. Project geometry will project this circle, boom, and this circle, and drop it in. Now, you'll notice it looks exactly the same as when we did this guy, the yellow color. But it didn't do it for this object, but it did it for the other object. The reason it did it for the other object is because I was using tangent. Tangent, 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 tangent. So the geometry, all this software keeps trying to get smarter and smarter and help you draw faster. And I've reminded people, so we don't want these products to get too smart, otherwise they won't need us, right? So we want it to be a little dumb. Well, here's an example where it's a little dumb. I threw my lines in there, but it doesn't know I want it to lock in to those two cylinders, so it didn't drop in any reference geometry for me to use. I have to put it in, and that's okay. Don't stress out over that. Now I can pick look at, so it can show me back to where I'm sketching. Hello. I don't need actually, I can pick look and look at, so I can look there and click where I want it to go. I can also just pick top because I know where I'm going. Now I have my two lines. I do need to trim them back. I don't see, notice how I don't see that the lines are in the part? How do I know they're there? Because I've done this before, and I drew the lines intentionally to be inside the part. A couple of ways for you to know. One, change your presentation of your view. So when we go to view, instead of having a visual style of shaded, maybe change it to wireframe so I could see through the object. Appreciate though when you do that, look how it looks in the isometric. It's visually challenging. Okay, so appreciate that reality. Let me rotate it in. So you might want to do this strictly to trim, or just remember that you need to trim, and then go back to the other look. Personally, I'm not going to do anything yet, because the next thing I want to do is assign the dimension that oh, I forgot that dimension. That one dimension on the drawing. This guy, 1.13. Remember that one? That is the distance between this point on the end of this line and this point on the end of this line. But when I try to use dimension and I try to get to that endpoint, the only thing I can ever get to is this, the actual angle. It won't work. The way to make it work is you actually have to draw in one more line that connects these two lines together. That is the line that you will dimension. Oh, I forgot. It only wants to give me horizontal and vertical again. What do? Right mouse button, aligned. 1.125. Whoa! They gave it to me, but wow, is it off center. Huh. How the heck do I fix that? Well, let's think about the geometry of this heart. If I drop in a line from center to center, I want this to be what with this? Perpendicular. So if I pick this line and this line, I can do perpendicularity constraint so they lock in. That way I'll have symmetry on both sides. Now I can dimension this side to here. What's this angle? But what does the customer give us? What does the customer give us? Does the customer give us this angle or do they give us the outside angle? Customer's looking at the outside angle. They're looking at this dimension here, from here to here. They're looking at the exterior toe in. They're not looking at the interior flare out. So I can't dimension this from the inside. The way to dimension it from the outside, and this time I'm going to be sloppy. I'm just going to go ahead and draw a line. I'm going to be random. Just going to touch the object. I'm going to draw another line on this side. Again, just being random. And I'm going to pick this line, and this line, and tell them all to be parallel to each other. Now I'm going to drop in my dimension from here to here, and I will get what I'm after. Is showing that it's 8 degrees from that position. 8 degrees from this position. That's how I'm going to achieve that. I can go back to view and change my visual style back to shaded with edges. And then go to home. And there's that shape. 1.12, 8 degrees in. When I try to extrude, you'll notice I was being sloppy. I did all solid lines. You notice that? Well, when I do that, now I have multiple ranges to select from. I don't know if you can see it clearly on the screen, but as I pick the different spots, you'll see that there's a subtle color change. I don't know if you can see it on the big screen. Not so clear up there. Guys, you can see it. You tell me. Is it visible enough? So you because I use solid lines, I don't get a clean, here's what I'm extruding. If I had turned these, which I can, turn both of these into something else. Right mouse button, construction. Okay? And took my center line and did the same. Now when I go to extrude, let me cancel this for once. I was too fast. It only gives me one option. It's the only thing I can extrude. I select this, drag my mouse up. The distance I want to extrude this is, the thickness is 0.375, and there's my next rip. Everything else you can build without any conversation, meaning You know how to draw. You know how to draw circles. You know how to make holes. The keyway you will have to build independently of the hole. Please remember that. This object here, you can use the hole command, and then the slot you will build independently. Just extrude cut. What you can't build without a little conversation is this dude out here. And there's more than one way to make it. So I'm going to focus on making that. First thing I'm going to do is go to the hole command so I can actually drill the through hole that goes into this thing. What diameter is that through hole, guys? Based on the image, it is 0.875. So the diameter of this hole is 0.875. How about I type it in correctly? Now you'll notice its location is somewhat what? Nebulous. I like that answer. That's a good, I like the way you said that. Nebulous. So to get it in the right spot, see how it says positions? I've got one position. I can't quite, it doesn't want to give me the center. Ooh, where did it go? It went off. Let's find out. Ooh, it went to the bottom. See that? Talk about nebulous. See that? It's a hole out in La La Land. Notice that? Nope, not went over there. It went dead center. Whoops, we don't want that to happen. Let's try this one more time. I'm going to go to this hole command. Placement, positions. It doesn't give me positions. When I drop it right there, base or location, sketch point, work point, what does it say? Okay, let's read that one more time. Let me drag it over to this side. Placement. Click a face and location, sketch point or work point to place hole centers. So when I pick the face first and then I go to the hole command, it doesn't care. There are no presets set in here, so when I drop this thing, it doesn't know where to go at all. It's completely absent of direction. When I type in the diameter, it's still absent of where am I putting this thing. It doesn't know where to go. If I pick like an intersection, it's just literally floating around. So what I need to do is what? What does it need in order to locate itself properly? It needs some kind of reference. Pick the side wall of the part. Did you notice that? Let me undo. One more time. Hole. Pick where it's going to be. Now you see that? Instead of trying to drag it all over the place, pick the side wall of the part. It finds the center of whatever side wall you selected. Point 875. Whoops, extra point 87. There we go. See? That's what you need to remember. And you hit OK. I go home. There's the hole right there. The other holes you would build the same way. Now, the fun part. Drilling in that hole on the side wall. We know to put planes in already. So if we do need to put in a plane, first thing we have to do though, before we can put that plane is, we talked about axes before. We did it on the other drawing. We're going to drop in an axis here, and then I'm going to draw a plane that is accommodative. You see that? literally lined up with both axes. And that gives us what? The 45-degree mark. Now, I hate to do this to all of you, but is that hole set to 45 degrees? If it was, we're done and we can move on. Nope, 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 nope. What's that set to, guys? "30 degrees. Yes, I'm trying to make a 30 with my mouse. There we go. So what did the 45-degree angle do for us? Not much. If the hole was at 45 degrees, we're done. We're ready. We can drill it at any time. Gosh darn it, you willikers. Nah, that's not the case. So putting in this work plane didn't do anything for us, sadly. So we are going to just go ahead and delete it. I do always recommend deleting items that you're not using because they clutter the drawing. That's always my advice. So I still need my axis, I will tell you that. So let me open this up again. I still need my axis through the center of this object to do what will make this work, which is a reference at 30 degrees. Understanding when I say 30 degrees or when you say 30 degrees, when we say 30 degrees for this particular item, the 30 degrees is in reference to this. This position is what to this position? Parallel. You're correct. Yes, you're absolutely right. So the two positions are parallel with each other. So the 30-degree mark denotes the center position of that hole. That's where the center position is. It does not denote so the center of this hole is parallel to this 30-degree mark up here. And that is 30 degrees from, let me change the color real quick again, 30 degrees from here. With that is parallel to this. Try to change colors to make more sense there. So what I'm trying to get is a hole through the face of this object on one side only. And the reason I say one side only is, does it say through? Through all? No. It just says diameter 3/8. So it's not through. Like this says 0.875, 0.88 through, right? This one's through. That's not through. It's only through one side. So if I need to index to drill a hole, again, drilling a hole at 30 degrees from here, okay, I'm thinking I need to index my work plane. Again, I'm going to draw a top view of this so you can see what I'm saying. Normally I draw it on the board. Here's this position. That I thought was a straight line when I drew it. Oh well. This angle here is 30 degrees. My hole is going through it, which means I need, of all things, a line that is what to this 30-degree line? Let me change colors. This line is my line where the center of where my hole is. What is it to this line? Yep, perpendicular. So these two are 90 degrees to each other. If that's the case, what is this? So even if I drew a reference, that particular line I didn't want in there. If I drew a reference, this, what do you call this? This plane at that angle, which plane does my hole really reference off of? That perpendicular line, this guy, the one that I'm going to change colors on. Hopefully it's going to be, yeah, this color. That plane is the one that matters, the one that I just tried to circle in purple very badly. That's the plane that you really want. Okay? With that in mind, we got to lay it out over here. Got it on paper, hand sketched it out, mouse sketched it in my case. Now we got to sketch it out over here. So if I go to the top view and I look at this thing, that's what we're talking about, over this. I can't overlay, I can't draw on the board because it won't transfer to the video. That's why I have to do it over here. And my pen won't work here. All right? So I have to show it off over here. So here's the two circles, and that's what I want to create. Again, 30 degrees. It's exaggerated here, but I need it 30 degrees. So when I go home and I look at this, I've got my axis, so I'm going to go here, create a plane, drag my plane, and I'm going to pick my, I dragged my plane. Gosh darn it, gee willikers. We had this discussion, a couple of us together, about if I drag the plane, can I pick other entities now? No. So I need to not drag the plane. That was the issue one of you was having for sure. So what you do is you pick the plane, you pick the plane, you pick the plane, you don't drag it, you pick the plane, because we're used to dragging it, and then you pick the axis that you want it to go to. Now which one did it pick? What angle did it select? It picked what to this plane if I drop it this way? 90 degrees. 90 degrees. If I go in here, it wants to drop this. See this purple? That's the plane it wants to drop. So if this is 30, what's this? $30 plus something adds up to 90. Yep. So if I made this 60, am I where I need to be? Now look which way it rotated it though. It's pretty extreme. Now inclusive and exclusive. I know this is all of a sudden has turned into a geometry class. Inclusive angles, exclusive angles, complementary. I can't draw on the screen, sadly, otherwise I could show you what's happening over the cat. All I can show you is this is going at an extreme angle. And that extreme angle is, I can't put it in there. I think I'm going to have to slow down and just draw it. Draw the 90 degrees so you could see it. Here's this 90. I'll leave that in there. Okay, there's the vertical. Right there. Okay, that's this crazy thing I just drew. All right?
45 plus 30.
Yeah.
45 after that 30.
Yeah, 45 and the 30. If I do this, now I can rotate this one, pick this plane, pick this object, and I'm still in the same boat, but at least now you're going to see what I'm doing. If I type in 60, now do you see what it's doing? If I type in negative 60, now do you see what it's doing? This hold on, sorry. This alignment right here is what to here. Perpendicular. This, I can't draw in there. Let me try this one more time. Because I've got this line. This is the one line. That's this line. What I just drew, oh, I erased a little too much. If this is the line that's drawn, this is the line I want to achieve. To get this angle, this direction, let me see if I could trim. No, I can't. Throw this here. This angle is 60 degrees. Because that's how I'll get 30 here and 30 here. So that this is, because 30 plus 30 is, so you'll get your 60, I can't draw on the screen. You'll get your 60 degrees. This is the tough way to do it. You have to actually know what you're drawing. Another method is the method we used in the previous drawing where we did the inclined plane. Remember that inclined plane drawing? What did I have you build? A sketch. I had you build a sketch. And I had you build a sketch that referenced your angle information. So there's my angle, and here's my dimension. Almost. Here's my dimension. This is your 30 degrees. Right, now that I threw that in there, now watch. When I go to work plane and hit plane, pick my center axis, pick my line, go to my top view so I could see this. Type in, what was that angle? I forgot. 60 that we were looking at? Negative 60? What do you notice, guys? Now do you see it? It's perpendicular. See the green line? The green line is the center direction, the direction of the hole, the center line. Think of it that way. Now do you see the 60? Now, if I take it a step back, before this existed, and delete that, I don't want to delete anything else, I just want to delete that. Alright, so here we have this. I'm going to edit the sketch just so I can, I'm building this for the sole purpose of conversation. So you see that angle, then I drop in my, I want to drop in a dimension, but now all of a sudden I don't have my line, because what did I just do? I deleted it. So I'm going to drop in this reference line, drop in my dimension now. There's my 30 degree marker. Okay. This is not attached to anything. I'm about to lock it in. There it is. Finish that sketch. Now I have some reference geometry for myself. Now I can actually go ahead and pick this axis. I gotta go into plane first. Pick this axis, and what else? What can I pick? If I pick any of the other objects, what will I get? A whole bunch of angles. You notice that? If I pick that, go to my top view. Now I can control my angle. What was it? 60? Was that what I wanted? Negative 60? See it? So I don't need to make two planes to get this done. I just need to know my math, my dimensions, the geometry associated with what I'm making. And even if I don't have a clear picture on that, if I put in my reference, a reference sketch for myself, the same way I had you do in the other drawing, that reference sketch helps me build this thing. because I know where I'm moving now. I know where I'm going. So you don't have to guess at it. You can always take the sketch and just not have it visible anymore, because now my plane is the correct orientation. Now I'm going to show you how to create a plane literally on the face. Watch. Plane. I pick my plane that's in the correct orientation, and I'm going to pick the face of my circle, of my cylinder. When I pick that face, guess what? Holy cannoli. It's tangent. Parallel with my plane. I can't do that otherwise. FYI. I can make the plane parallel to that face of a cylinder if I have something to reference from to make that happen. And in this case, I chose to do it by putting a plane in. There you got it. So, this is the place where I drill my hole. I can do it right here on the face of the part. Because the hole command needs a place to go. It needs a plane, a face to attach to. What else does it need? I'm going to go in this plane. What else does it need? It needs an anchor of some kind. So I jump to the hole command, but I don't really... Where am I putting the hole? I'm going to drill a hole. Anytime you drill on a round surface, what do? Where's my machinist? It's in a particular kind of vise, right? So that the part doesn't turn, doesn't rotate on you. What's another way? What do you put in the center of it? You put a little mark? What's it called? Yeah. Right. So what you do is you basically tap it, you touch it, so it makes a little point. So when the drill goes in, it sits into that point, so it drills in that spot. So what we need to do is our equivalent of that on this round body, using this plane, this new plane. If I go home, I pick that plane to build on. So now I'm in this face. I actually add a point, literally a point. That's what I'm doing. All I'm doing is dropping a point. Now where my point drops, you notice how it moves everywhere? So what should I do? I should do something. We talked about this thing. I like this command. Project geometry. So I'm going to make some kind of reference for myself. What is this? What can I project? What are the different things I can project? Let me go to isometric. There. What are the different types of things I can project? I can project an axis. I can project the face of some object. I can project other objects. But what I need for this guy is what? The axis. I need to project that center. And voila, I did. Once you project that center, then I can take this little cross, let's get out of the project geometry command first, my mistake, drag it over so it touches it and locks onto it. The next thing I need to add is where vertically, because now this little point moves up and down. Where do I lock it in vertically? Again, remember there's more than one way to build this. I'm just showing you one method. Where can I lock this in vertically? Let me go back to my sketch. I need to lock it in half an inch. It looks like half an inch down. So that's a dimension. So I just go ahead and drop a dimension from up here to here. It's 0.5 down. There we go. I finish my sketch. I go to my hole command. And blammo! You see how it just picked it? Isn't that beautiful? That's what you want. It's exactly what you want. Again, this is only one method of building this. I actually built this thing multiple ways in the past. So you just play with it. I want you to play with it. But this is another way to use planes. It's my opportunity to show you the other method of planes. The diameter of this hole is 3/8 of an inch. So I'm going to change this to 0.375. Is it through all? Nope. We had that conversation already. It's only through one side. So when we look at our settings, the termination has a 2-point, not a through. So we can select that interior surface. But notice how, I don't like that. I selected the interior surface, but it looks like it wants to touch that back wall. I don't necessarily want to do that. It can't tell where the surface ends. So what's another way? Can I pick something different? I can pull it back a little bit to next. Now it's kind of hung up on wanting to go there, so let me try this one more time. Hole. That goes through. My choices. The drill point doesn't matter unless you actually have to mill it flat, just so you know. Mine wants to go to just the that interior wall. But let me see if I pick the interior wall on the other side. And it still goes kind of deep. The diameter is bad, 0.375. Let me fix that real quick. It's still, even though I picked the other side of the interior wall, it still looks like it's going all the way through, but it does stop flush with that back wall. I can always pull this back if I'm nervous and I don't want it to go there. It won't matter, but just so you're aware. If I just say 1/2 inch, that's fine if that's what you want to do. Or you can leave it alone and just let it go. Just to the interior wall and be done with it. Alright, guys? Cool? Doesn't matter. When I hit OK, you're not going to get a blemish on the back wall. If you were worried about that, that's what I wanted to show you. You will not see a blemish on that back wall. That is how you drill a hole at any angle. You just have to know the angle. In our case, we happen to be dealing with something at 30 degrees on a round surface. Not even on spheres are more challenging, just because you have to know where on the sphere you want it. But the process is the same. This at least had a flat surface area that I could use. I intentionally drew my little sketch there as a reference so you could see what was happening, because I couldn't draw it on the board for you. All right, so hopefully this helps you when you're working on this project. That ends this video.